Hello everyone. I'm going to talk about teaching mathematics through problem solving, a pedagogical approach from Japan. In Japanese, we call mondai kaiketsu gakushu. Mondai means problem. Kaiketsu means solving. The gakushu means study. So the English translation, we say teaching through problem solving. The idea behind of this approach is I'm going to use the quote from Professor Sugiyama, one of the leading mathematics education researcher in Japan. Simply showing the products of somebody's work will not help learners to see the thought process of coming up with new ideas. The teacher should provide opportunity for students to know the thought process by themselves. So, simply, typical elementary school mathematics class is 45 minutes. Use one problem for 45 minutes and then let them solve by themselves. If you do not tell students how to solve the problem, naturally there are several different approaches coming from students. So after students coming up their solutions, including some incorrect solutions or misunderstanding, teacher facilitate discussion to help students learn something new. That's a mondai kaiketsu gakushu. This means the solving problem or getting answer is not the most important goal of teaching through problem solving. Teaching through problem solving is students want to learn something new by looking back their solutions and then have some discussions. The development of TTP in Japan and teaching through problem solving is a accumulation of a major education reform movement in Japan. In 1958, the Japanese national curriculum introduced a new term, mathematical thinking, which is 数学的な考え方 in Japanese, in order to highlight its importance. The translation of books such as Polia's How to Solve It or Teaching Problem Solving written by US researchers become very popular. And then NCTM Agenda for Action also influenced to Japanese mathematics education community. The Agenda for Action said the 1980s should be a decade for problem solving in mathematics education. The 1989 national curriculum specifically stipulated that the purpose of teaching mathematics is to nurture student mathematical thinking. So the mathematical thinking, which is a process of mathematics, become much important than the product. So by 1990s, TTP became a major pedagogical approach for teaching mathematics across Japan in most elementary schools as well as in some lower secondary schools. How this happened? Well, the teaching through problem solving is the product of lesson study. Teachers work very closely with researchers and then the team of teachers coming up variety of ideas to develop teaching through problem solving lessons. This is not only like Japanese unique ideas, but around the world, 60s, 70s, 80s, there's a huge emphasis on the problem solving. So this is a quote from NCTM, Principle and Standard for School Mathematics, which is published in 2000, Build New Mathematical Knowledge Through Problem Solving. They define the problem solving means engage in a task for which the solution method is not known in advance. That is, the same problem can be a problem solving or not, based on the student's prior experience. If students do not see the problem prior to this, it can be problem solving. However, if the student sees the similar problem prior to this, or a teacher helps student to show how to solve it, it's not going to be a problem solving. This is we call exercise. That's the difference between problem solving and exercise. And then NCTM emphasizes that the good problem gives students the chance to solidify and then extend their knowledge and to stimulate new learnings. Therefore, most mathematical concepts can be introduced through problems based on familiar experience coming from student lives or from mathematical context. So, we should teach mathematics by giving students problems which they have not seen before. The problem solving is an integral part of all mathematics learning, and so it should not be isolated part of the mathematics program. That is a quote from the NCTM standard, which means still we see many textbooks in the United States. You can find the problem solving at the end of chapter, which is not a good idea. We should introduce new idea, which means even like an opening of the unit should ask student to solve the problem he or she has never seen before. And then through the discussion, help them to learn new concept. So therefore, choosing a problem or mathematical task is quite important. Many interesting problems. However, if this is not appropriate for the student at the particular time, it can be exercise, not necessary to help a student to learn something new. Let me share my experience when I was a novice teacher in Tokyo. As you may know, the Japanese school system, they have a professional development regularly throughout the school year. And then typically a district have a half-day PD every month. And then on this day, they have several research lessons in a district schools. So, for example, one school has a science lesson. Another school has a mathematics lesson. Another school have a language art lesson. So, as a teacher of the school district, you can choose which school you are going to go and then observe a lesson. So in my case, I was interested in teaching through problem solving. So I went to the school to see the lesson. That was in 1979. When I was a student of the elementary school, middle school, high school, I was taught in a traditional mathematics classroom. That means teacher basically tell something important and then let us do the exercise. However, when I become a novice teacher, the problem solving become a big emphasis. So I really want to learn how to teach it. On the district day, the teacher, when I went to the research lesson. The teacher begin by telling the students that they are going to do the game. Okay, so teacher say, let's play a game of ring toss. Students say, yeah, sounds fun. Or let's move all the desks and chairs to the back of the classroom so that we can have enough space to play. Here's a diagram showing this. In the classroom, as you may know, the Japanese, the typical schools, they have up to 40 students. There are a lot of students. And teacher say, each of you will get a link to throw. Everyone will line up on this line. So this is a line that the teacher showed to the student. And then they're gonna throw a ring at the same time. And then whose ring land on the pole will be the winner. However, the students start complaining. Well, teacher, it's not fair because I have to throw from here, but somebody throw from there, which is like much closer to me. And teacher say, okay, why don't you come up with a better idea? That's the beginning of the problem solving. Some students say, oh, maybe V shape? Some students, well, how about square? And another student say, oh, how about a circle? Kind of. And then the teacher asked a few volunteers to come stand around the pole to help to figure out how you do this. So students say, I tried to come up with a way that each of us would be the same distance from the pole. Do you think if we line up using your ideas that all of you will be the same distance from the pole? Oh yeah, we can try and see it. So they bring like strings, and then we can use the piece of strings to measure to make sure we are all in the same distance from the pole. And then students start saying that it should be a circle. Teachers say, okay, well, let's use the piece of the strings to help us make sure that everybody stand on the equal distance from the pole. And then everybody become happy. So I was kind of shocked because teacher never talk about circle, and teacher never talking about the definition of circle. Student knew the circle in everyday life. However, they do not know the mathematical definition of the circle. But it's come from student. Now it's become a textbook problem. So this is the one of the 6 government authorized Japanese mathematics textbook available now here. So this is the opening of this circle unit. And it's kind of similar games. By the way, if you are interested in this like English translation of Japanese mathematics textbook series, it should be available through Amazon. So I'm gonna give you information later to the organizer. So if you are interested, you can purchase through Amazon. It can be the Kindle book. So all grade 1 to grade 6, you can get this one. So that was kind of beginning of the movement toward teach by telling to teaching through problem solving. And then seeing is believing. I was so interested in observing this research lesson, and then, well, I want to try such kind of lesson. During that time, Japanese teachers emphasizing the 3 different levels of teaching. The level 1, the teacher tells students essential mathematics such as facts, concept, procedure, and then practices. So basically, if teacher know mathematics, you can tell student, you can teach it. That means anybody can be a teacher if you know mathematics. Even like a high school student can be a teacher for their younger brothers and sisters. Level 2 teachers. Level 2 teaching, the teacher explains the meaning and then reason of essential mathematics, such as facts, concept, procedure, and then practice for the student to understand them. For example, if you multiply by 2 digit by 2 digit, Well, you have to, using a formal algorithm, and you line up in vertically, and then multiply by ones and ones, ones and tens, tens and ones, and tens and tens, and then add them all. That's a procedure. Level 1 teacher teach step by step so that the student can see the procedure. However, if the student asks a question, well, teacher, when we add two-digit number and two-digit number, we wrote a kind of similar way, like a lineup place by place. However, only we need to add is ones and ones and tens and tens, only twice. Why we have to multiply by 4 times? A level 1 teacher say, oh, don't worry about it. Just do it. That's the way you have to do this. But level 2 teacher can explain why you want to multiply by 4 times, why you need to do so. So, but level 1 and level 2, it's a subtle difference. Level 2 teacher, they have a special set of knowledge just for teaching, which is a beginning to be a professional teacher. But level 3 is a teacher provides students with opportunities and then support their learning to come up with essential mathematics, such as fact, concept, and procedures, and then develop mathematical practice, so that the students become independent learners. So we want every single student, teachers, to be a level 3 teacher. Well, if this is a level 1, level 2, basically teacher teach mathematics to the student. However, level 3, teacher not necessarily teach mathematics to the student. However, teacher should be able to design a lesson and then facilitate discussion so that the student can learn mathematics. For this online situation, the weird situation currently we are facing, level 1, level 2 teaching relatively easy to use for the remote learning because teacher just telling student, explain to student. However, level 3, interaction among student and teacher, which is not so easy in remote learning. Let me explain the typical flow of 問題解決学習. First, introduction. Usually, teacher helps student to look back on previous learning and then be ready for solving problem, which is about 3 to 5 minutes. Then posing the problem of the day. Because of the problem students have never seen before, and teacher helps student to grasp the mathematical challenge. What is a challenge? What is something that we have not learned yet? It takes like 5 to 7 minutes. Then student are asked to solve the problem by himself, by herself, independently. And during that time, teacher monitors student as they are working independently to be ready for the following discussion. So how students solve this problem? Who is struggling? Who come up with which solutions? And then by using this, but teacher typically use sitting chart while they are working in between student desks and then monitor and then coming up the plan for the following discussion. Comparing and discussion called Neriage. And this is the heart of teaching through problem-solving lesson. Therefore, teacher usually plan 20 to 25 minutes, which is the largest chunk of the time. After this discussion, and teacher summarize and using the board writing typically. Leads the student to look back on what they have learned, which is 5 to 10 minutes. This is a typical flow of teaching through problem solving. However, as the unit progresses, it can be slightly different. Let me use the current textbook series about the unit of circle, which is grade 3. So the day 1 lesson, teacher asks student to attack this problem. and then coming up ideas. So the lesson 1 is making the Ringtos game fair. That's a problem solving. Lesson 2, which is usually next day, define circle based on the previous lesson, and then exercise using the definition of exercise, which is at the day 1 lesson, they coming up kind of naive approach for the coming up the definition. However, lesson 2 is kind of secure their understanding, and then give some challenging problems like draw many different size of round shape using the tool on a tool given by the textbook. And then by comparing this, they formally define, which is a day 2 lesson, which is very different from day 1 lesson. And day 3, in using these kind of definitions to kind of extend, deepen their understanding, find a way to identify the radius and hands-on investigation. For example, how many centimeters is the length of the radius of this circle shown on the right? How are you going to find this one? This is going to be hands-on investigation. Teacher may give this circle on the paper and then let them figure out by folding this. And lesson 4 is the learn to use the compass to draw a circle. So this is the kind of typical flow of the unit. Begin with teaching through problem solving. And also, day 4 lesson, you have to teach how you use compass. So which is something we need to teach students. And then how you teach it, let them use to draw this design like this. And this is an example. And then also they can come up by using this one to getting familiar with this new tool. And lesson 5 is extending their understanding to the different situation. In this case, the teacher gives students opportunity to use compass to copy the distance. And also this is more hands-on activities. So you see, the Japanese textbook is designed around teaching through problem solving. And some things that new knowledge, you have to clearly teach it. New tools, you have to introduce it and let them use it and practice. However, also they can extend how you use this one. Teaching through problem solving. So you can see, the teaching through problem solving any place in Japan. This is an interesting result at the TIMSS 2003. As you may know, TIMSS are the same set of assessment items are sent to each countries. However, the country by country, their curriculum are different. So here, this is average score. That means if you go high, that is better. So the horizontal side is average percentage of TIMSS mathematics topics taught in the school earlier, either prior or during the school year. That means, entire set of the items sent to the country, how much portion of these items are students already have learned. So international average, 73% was taught. However, only 53% was correct. So even though you teach, but it's not guaranteed that the student can, learn 100% of this. Singapore, you teach they teach 80% already of the items that they already have learned. However, 74% was correct. That means if you teach more, you teach better. You learn better. However, United States, it's interesting. Same as the 82% of the items students already have learned. However, only 58% was correct. So there is a huge gap between what they teach and what students learn. Like international studies, they talked about this is intended curriculum, actually the implemented curriculum, and then this is attained curriculum. So that the gap between what they are taught and then what they actually learn. Whereas Japan? Japan is they only learn 54%, and then they correct 69%. Interestingly, by them, students are getting familiar with seeing that the problem which they have never seen before. So even they have not learned yet, but they can attack this problem by himself, by herself. We could say this is a result of teaching through problem solving. So this is a very short introduction of and then brief history of Japanese mathematics teaching through problem solving. And if you want to know more, so my talk is based on the upcoming book, Teaching Mathematics Through Problem Solving, a Pedagogical Approach from Japan, and which will be available in March 2021. So unfortunately, it's not ready yet. However, I'm give this information to your organizer so that you could get the information. And also good news is I have a code for 20% discount. So maybe you can use and then order from Routledge. It's gonna be a hardcover and soft cover and an ebook. So I really, encourage you to read this one because this book is not only like talking about the teaching through problem solving. However, there are a lot of the examples from Japan, and then also I explain how you design the researches. Also, the lesson study is how it helps you to coming up the teaching through problem solving lesson. Thank you very much. And I'm gonna have a Q&A session following to do this. So you are welcome to ask questions for me.